Okay, folks, here's problem number 5 from 2012. And this is where it gets a little bit different for us. This first one is going to really kind of, again, it's open note, folks. So I'm giving you about 13 problems that I feel are very possible for the test. You get to use these. I just want you to understand that we are currently in the section of what we call separable and differential equations. AP Calculus has this as Unit 7. Okay, and then they have area and volume, which we got done doing as Unit 8. Well, they got rid of Unit 8 altogether, which, in my opinion, was a huge mistake on their part. Traditionally, in colleges, this is taught in Unit 6, where we covered it, so we were good there. And then separable and differential equations often is not even part of a Calculus 1 course. It's Calculus 2 or it's a differential equations course. So we ended up not covering it. So here's kind of your just real, crash course in this situation. But it talks about a bird, and the bird is born and it weighs 20 grams, okay? And this is the rate. So dB over dt, that's like saying B prime is equal to this guy. So the B is the weight of the bird. So this is the rate at which the weight is changing. Rate, weight is changing. So the first question is the bird gaining weight faster when it weighs 40 or when it weighs 70? Well, we just type in 1 over 5 times 100 minus 40, which is 1/5 of 60, which is 12. So that's 12 grams per day. Okay? And then 1/5 times 100 minus 70, which is 1/5 of 30, which is 6 grams per day. So gaining weight faster when it weighs 40 grams. And I hope that makes sense to everybody because the fact is that when it's smaller, it's going to be gaining weight more quickly. So that should make sense, okay? All right, part B, this is where it gets a little bit complicated. It says find, this means the second derivative in terms of B. And I'm going to rewrite this up here so you understand. That's really another way of saying y prime is equal to 1/5 times 100 minus y. So the derivative of b with respect to t, it's like there's a y in both situations. If you remember, we find y double prime, that would be equal to, the constant just stays alone, 1/5 times 100 minus y. Well, what's the derivative of 100? It's 0 minus, and what's the derivative of y? It's y prime. Well, what are we going to put in place of y prime? We're going to put this guy right back there. So y double prime is equal to 1 over 5 times negative y prime, or y double prime is equal to 1/5 times negative 100, I'm sorry, 1/5 times 100 minus y. And so 1/5 times negative 1/5 is y double prime is equal to negative 1 over 25 times 100 minus y. Now it says to solve in terms of b. I left it as y just so you guys could understand, but this means that b double prime is equal to negative 1 over 25 times 100 minus b. And so that's the second derivative. That's the second derivative, okay? In terms of b. Now, it gives us this interesting question about the graph. It says, explain why the graph of b cannot resemble this graph right here. Well, let's think about this, okay? It says that if you look at the graph here, we're going from 20 to 100. So that's the weight. That's B. So say that B is somewhere between 20 and 100. Would you agree that this is always positive and that this is negative? So you're going to get negative times a positive, which is negative. So B double prime is negative for B between 20 and 100. That means, what does it mean when a second derivative is negative? Second derivative negative means that the graph is concave down. That means the graph will be concave down. The given graph is concave up for a portion. So if you look here, look at the graph, here it's concave up, and then here it's concave down. So that way we know that it can't be the correct graph. And finally, C, this is where you might get thrown for a loop. Please just be patient. We're going to do 2 more problems, and I think the other problems you're really going to connect with, but this will really help you if this type of question gets asked. It says, use separation of variables to find y equals b of t, the particular solution with the initial condition 0, 20. And so this separation of variables thing, dB over dt is equal to 1/5 times 100 minus b. Here's the deal. You want to get any part of the expression that has a b on the side with dB. And you want to get the dt on the side of everything else. So if I multiply both sides by dt, I get dB is equal to 1/5 times 100 minus b dt. Then if I divide by 100 minus b, I get 1 over 100 minus b dB is equal to 1/5 dt. If you could just separate the variables like that, they will give you points. Now, in order to find the particular solution, we make the dB and dt go away. The way we do that is we take the integral of both sides, or the antiderivative. This is easy. The antiderivative of 1/5 is 1/5 t, okay, plus some constant. The antiderivative of this, well, we kind of just talked about that. If you notice, it's going to be natural log. And then because it's a negative b, it's going to be negative natural log of 100 minus b. Now you could put plus c, but it doesn't matter if we have 2 constants. We'll just solve for 1. So the initial condition says that at time equals 0, we know that b is equal to 20. So if I use that, I get negative natural log of 80 is equal to 0 times LB 0 is equal to c. So I know c is actually that value. Now I can go ahead and solve. I go back to the negative natural log of 100 minus b is equal to 1/5 t minus, because c is negative natural log of 80. The goal is to solve for b. That's what it means when it says solve for the actual equation. I'm going to get rid of the negative, so natural log of 100 minus b is equal to natural log of 80 minus 1/5 t. How do I get rid of natural log? I create a base of e. So I have 100 minus b is equal to e to the natural log of 80 minus 1/5 t. Get rid of the 100 by subtracting 100. Get rid of the negative by dividing by a negative 1. And so there's a couple ways to write this. And if you wrote it like this, it would be correct. But I'll show you the way that they actually write the answer in case you're interested. First of all, you'd have 100, because it would be positive, minus e to the natural log of 80 minus 1/5 t. Okay? And furthermore, when you're subtracting, we can rewrite this as 100 minus e to the natural log of 80 over e to the negative 1/5 t. You can see e and natural log cancel, so 100 minus 80 over e to the negative 1/5 t. And since I have a negative exponent, I can bring it up here, 100 minus 80 e to the 1/5 t. I'm going to check my answer here with the answer key. I haven't looked at that yet. And that looks pretty good, except somehow this should be negative. So I made a mistake somewhere on that. Got a point off. My bad. B is equal to that guy. That'll be our answer. So, all right, that was 11 minutes. I'm going to see if I can pause here. My bad. I found it. Easy mistake here. When I wrote this as subtraction, this should have been a positive right there, 1/5 t, and then positive 1/5 t. And now as you bring it up to the numerator, it will become negative. My bad. Would have cost me a point without a doubt. 8 out of 9 on that one. There you go. Tough problem. The next couple are going to be easier. Promise.